So now under this we have the type is series static synchronous series compensator. So triple SC. Okay, so the basic part, the construction, all this thing we have already completed during the first and during the time of that series compensator. So now let us see static series compensator, just a recap. So same thing it will be, only thing is later on we will have like VI characteristics and all this thing in addition to the what we have done in the previous classes. So just a recap, you can say the VSC based series compensator called this SSC was proposed by this Kugi in 1989 within the concept of using converter-based technology uniformly for shunt and series compensation, as well as for the transmission angle control. So this one was the main concept for proposing this triple SC. So just for the recap one, it was seen in the StatCom section that voltage source converter, that internal control can be considered as voltage source, synchronous voltage source, which is analogous to the electromagnetic generator, means the synchronous generator. We have seen the synchronous generator. Okay. So where in this case synchronous generator, where it produces a set of 3 alternating or substantially sinusoidal voltage at the desired fundamental frequencies, that is another point, which can generate or absorb the reactive power. Okay, so generate during the excited under overexcited time, and then absorb during the underexcited time. And also it can change the rail power with AC system when it is connected to a DC source or storage. So that we have seen. So this is just a recap from the StatCom. So StatCom can either generate or absorb the reactive power plus exchange the active power with the DC AC system if there is a storage system. So now this one was there. Now similar to this series compensation, so which is analogous to the StatCom, we have is triple SC. So this you can see the functional representative of that synchronous voltage converter. Synchronous voltage converter is shown here. So this is your synchronous voltage converter here. Okay, so function. So now here the references Q ref, the reactive power reference, and active power reference, or X ref and R ref defines the amplitude and the phase angle psi. So amplitude and phase angle psi of the generated output voltage, which is necessary to exchange the reactive and active power. Okay, so that is there. So it defines that. This will define this. So now another point here, if the SVS, if this system is operated strictly for the reactive power exchange only. Okay, so if it is only for reactive power, if this system is operated only for this reactive power system, then P reference or R reference is set to 0. Means you can remove this part, which means this energy storage is not there. We are not considering this. If SPCS just operated, then we will not have P. So that time what you'll have is V is equal to V sine phi t minus S psi. So which means the energy source is not required. If SPCS is just to operate for the reactive power exchange, then this energy source is not required. This is not required. Okay. So this you keep in mind. So this is actually analogous to the StatCom solution in shunt compensation. So this is analogous to the StatCom. So during the StatCom here you have this. So when VO is greater than V, then it will generate the power. When V is greater than VO, it will means it will supply, this system will supply to the StatCom. So analogous to the shunt compensation means the StatCom in the shunt compensation. So now let us see the operating principle. So just it will be recap. Okay, same thing we have, which we have discussed in that the previous case. the basic operating principle can be seen. So this we have already seen. So I will not touch much here. So just you go through. It is already there. You might have already gone through this part. Last time only we have seen. Just you go through. If you have any doubt, then you can ask here. So this one we have. So here now series in triple SC, we are replacing this here in series capacitor. This one was XC was there. So now we are replacing by the alternating voltage source. Okay, so synchronous AC voltage source is replaced instead of this capacitor. So in previous case you have is, so this is your basic simple, this series capacitor is there. So now in triple SC this is replaced by synchronous voltage compensator, so, or voltage source this. Okay, so that is what you will have. Same you have last time. Then another point you can have operating. So the power, transmitting power, just you can see the power which is given by this. You can see now. So this is the power equation we have got. So for triple SC, even at angle is equal to del is equal to 0, there will be a power transfer. So at del is equal to 0, this will be 0, but this will not be equal to 0 at del is equal to 0. So because of that, the power will be, the triple SC will transfer the power even at del is equal to 0. Means it is independent. So the power transfer of the power transfer or power controlling capability of the statecom, this static triple SC static synchronous series compensator is independent of del, whereas STANCOM it is independent on dependent on del. Okay, so uncompensated, then after compensation you will this. So power handling capability is increased even at del is equal to 0, power can be transferred. Okay, so this is the case. So this is what you have. See the normalized. Now when you plot without compensation is this. The power transferred by the system without compensation. This is. Now with compensation, when it is compensated or when the VQ is given, say suppose the voltage is given at point this one, series voltage is connected, voltage source is connected of around this one, then the power transfer is increased to this. Then similarly, when it is given increased to 0.707, again it has increased. Okay, so this is the case of the power transfer, it is increasing it. So now if after at compensation, when there is no compensation or when that series voltage source is not connected, at del is equal to 0, power transfer is 0 here. Okay, so power transfer is 0. Now once that VQ is connected in series with the line, what will happen? Even at del is equal to 0, so del is 0 here, the power transfer is there. Okay, so this is the, even at del is equal to 0, power transfer is there. Okay, so that is what the means. So here, even at del is equal to 0, power can be transferred means, so from this can be proved from this graph. So this is the case. Okay, so for the comparison purpose, you can have this. So this is your series compensation. Series compensation at k is equal to this. So now you can compare these two. So you can compare these two. So you can comparison between this is due to series compensation, and this is due to the series normal series capacitor connected, and this is due to voltage source connected in series. You are replacing this. So normalized power plot. So this you can see here the maximum. But the thing is, here series capacitor increases the power by fixed percentage. So it is increasing here without compensation, with 0.2 compensation, means 20% compensation, and then here it is around 33% compensation you are getting this. Okay, so that is there. So here series capacitor increases the power by fixed percentage of that transmitted by uncompensated. So it is fixed at fixed percentage, whereas triple SC can increase power by fixed fraction. So it will fraction of the maximum power transmittable by the uncompensated line, independent of delta. So it is independent. Okay, so whether you increase or decrease, it is. So even at del is equal to 0, the power is transferred here. So even at del is equal to 0, the power transfer is possible. So here, but this is not possible in case of series compensation, normal capacity series compensation. Okay, so this is the advantage of triple SCD. Even at del is equal to 0, you are able to transfer the power. Then another point you can have is this SSC, triple SC can decrease as well as increase the power flow to the same degree just by reversing the polarity of the injected AC voltage. Okay, so 180 degree phase shift degree. So if VQ is greater than sending end voltage, magnitude of sending end minus receiving end, then power flow will reverse with line current. So this is, so it is going downward. Okay, so when it is reversing, so below them. Then this is compensation, positive compensation for power flow, negative compensation for power flow. Okay, so this compensation without. Then now this one will be new for you, the control range and VA rating of SSC. Control range and VA rating of triple SC. So now triple SC can provide capacitive or inductive compensating voltage independent of the line current up to its specified current rating. So this one up to this. So this is your VI characteristics of triple SC, and the loss versus the current characteristics of triple SC. Okay, so this is the case. Then this is under voltage mode. So when it is under voltage control, so similarly control range VI characteristics there for everyone you have is, one is voltage compensation mode, another one is impedance compensation mode. So voltage here, voltage is kept constant. Then in impedance compensation mode, the triple SC is established to maintain the maximum rated capacity. Okay, so this is the case of the in impedance compensation mode. Okay. Then another one is practical application. In this we use is this hybrid triple SC. So this one we will discuss in next class. Okay, so we can have. So Ani, hello, excuse me, hello.
Yes, sir.
When you and class test, have you discussed with for the class test when you will be able to conduct class test?
Not decided particularly on the date, sir.
Direct phase test, sir.
Huh?
Direct phase test.
Well, phase testing machine and phase test we have to. We will know when to conduct phase test today, I think today we have CAC, so they will decide when to conduct the amnesty. Sangachi, we don't have anything. We have to follow the.
Sir,
Yes.
first test
Feast की टाइम टेबल
sir.
त अब डिसाइड भएको छ
Huh?
फेस्ट टेस्ट की टाइम टेबल त अब डिसाइड भएको छ लास्ट टेस्ट टी
If you are not able to decide, then I will decide, and then I will do Panji.
नो सर वी विल डिसाइड
Okay. Kezang is not there. Kinle Wangchu. Kinle Wangchu not there. Then others 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 18, 19. 19 do 20, 21. Next to those.
Kilowatt is there, sir.
Kinle is there. No? Except Kezang, others are all present, no? Okay, so Anji, please, then Ani, you have to study, okay? And study, please, because we never know what will happen. Then Ani, exam semester end na begos then we have to be ready. Class test we will do the class test the basic class test the basic face test the gadir so they will discuss today. Okay, so then
Sir, network, sir, network, sir.